Hello and welcome back to the channel. Today we are diving deep into one of the most critical technological races of our time, the semiconductor industry. Specifically, we are looking at China's latest chip technologies and chip production capabilities and how they stack up against the West. This is not just a story about technology. It is about economic power, national security, and the future of global innovation. So grab your favorite drink, get comfortable, and let us explore what is really happening in the world of chips. Before we go further, please subscribe to my channel. We need your support to continue to bring you honest reports and analysis of major events around the world. Section 1. Why chips matter more than ever. Before we get into the details, let us briefly cover why semiconductors have become so important. Chips are the brains inside everything from smartphones and cars to military systems and artificial intelligence. Whoever leads in chip technology leads in economic and strategic influence. For decades, the United States, Taiwan, South Korea, and parts of Europe have dominated this field. Companies like TSMC in Taiwan, Samsung in South Korea, and Intel in the United States have set the pace for innovation. But over the past 5 years, China has made semiconductor self-reliance a top national priority. And the results are starting to show. Section 2. China's current chip production capabilities. So where does China stand today? Let us start with the numbers. China's semiconductor industry produced a record 484.3 billion units in 2025, representing an 85% increase since 2020. This massive growth reflects both government investment and surging domestic demand. At the center of China's chip ambitions is SMIC, or Semiconductor Manufacturing International Corporation. SMIC has successfully established production of 7-nanometer chips using deep ultraviolet lithography equipment that was stockpiled before international restrictions took full effect. This is significant because 7-nanometer technology is considered advanced, though still behind the cutting edge. SMIC monthly production capacity has grown to over 1 million 8-inch equivalent wafers, with utilization rates remaining strong despite global market fluctuations. The company is also planning to add roughly 40,000 12-inch wafer equivalents per month in capacity by the end of 2026, signaling continued aggressive investment. But capacity is only part of the story. What about the technology itself? Section 3. Key technological breakthroughs. China has achieved several notable milestones in recent years. In January 2026, China announced a major breakthrough with the successful development of its first domestic tandem-type high-energy hydrogen-ion implanter, called the Power 750H. Ion implanters are one of the 4 essential tools in semiconductor manufacturing, alongside photolithography machines, etching equipment, and thin-film deposition systems. This development is expected to reduce dependence on foreign technology in a critical segment of chip production. In lithography, which is perhaps the most challenging area, Chinese company SMI has moved its 28-nanometer RF immersion systems into the verification stage. While this is not yet at the extreme ultraviolet or EUV level used for the most advanced chips, it represents meaningful progress in a field long dominated by the Netherlands-based company ASML. In etching technology, Nora Technology Group has begun mass production of 28-nanometer tools, while AMIC is reportedly conducting verification of its 14-nanometer equipment at SMIC. These are important steps toward building a complete domestic supply chain. Perhaps most intriguingly, according to reports from Reuters, China has assembled a prototype extreme ultraviolet or EUV lithography machine using components sourced from older ASML systems. The Chinese government reportedly aims to produce functional chips with this prototype by 2028, though 2030 is considered a more realistic timeline. This suggests China may be closer to semiconductor self-sufficiency than many analysts previously anticipated. Section 4. How China compares to the West. Now let us address the big question. How does China's chip technology compare to what the West is producing? The short answer is that China has made impressive progress, but still trails in the most advanced segments. At the leading edge, Taiwan's TSMC is already producing chips at 2 nanometers, with plans to move even smaller. These chips power the latest iPhones and advanced artificial intelligence processors. NVIDIA's most powerful graphics processing units are manufactured at 5 nanometers. By comparison, China's most advanced mass-produced chips are at 7 nanometers, and these are produced in relatively low volumes using workarounds rather than state-of-the-art equipment. Chinese companies like Huawei and SMIC have managed to push deep ultraviolet equipment beyond its intended limits to achieve these results. But the process is less efficient and more costly than using true EUV systems. In terms of equipment, ASML remains the only company in the world that can produce extreme ultraviolet lithography machines, which are essential for manufacturing chips below 7 nanometers. China's domestic efforts in this area are still in the prototype phase, while ASML is already developing next-generation high numerical aperture EUV systems that will enable 1 nanometer production. However, it is important to note that not all chips need to be at the cutting edge. The majority of semiconductors used in automobiles, industrial equipment, Internet of Things devices, and many consumer products are made at mature nodes like 28 nanometers and above. In these segments, China is rapidly closing the gap and in some cases achieving self-sufficiency. China is also investing heavily in advanced packaging technologies like chiplet architectures and three-dimensional stacking. These approaches can boost performance by combining multiple less advanced chips in innovative ways, potentially offsetting some disadvantages in raw process technology. Section 5. The impact of sanctions and China's response. No discussion of China's chip industry would be complete without addressing the role of international sanctions. Since 2022, the United States has imposed sweeping restrictions limiting China's access to advanced chips, particularly those used for artificial intelligence, as well as the equipment needed to manufacture them. Under pressure from Washington, the Netherlands has also tightened controls on sales of ASML lithography machines to Chinese foundries. These restrictions were designed to slow China's technological advancement, but they have also had an unintended consequence. They have accelerated China's determination to build a fully domestic semiconductor ecosystem. China's response has been comprehensive. The country is not just trying to make chips. It is rebuilding the entire value chain. This includes producing silicon wafers, industrial gases, specialty chemicals, design software, and of course manufacturing equipment. Beijing has set a target of raising the localization rate of equipment used in mature process technologies to 70% by 2027. Chipmakers expanding new production capacity in China are now required to source more than 50% of their equipment domestically. This push is showing results. Validation cycles for Chinese-developed equipment are reportedly progressing more quickly than those for foreign-made tools, often being completed within about a year. Domestic adoption of Chinese chip equipment exceeded 35% in 2025, led by companies like Nora and AMIC. At the same time, China is leveraging its strengths in other areas. The country controls a significant portion of the global supply of rare earth elements, which are essential for many semiconductor processes. This gives China strategic leverage even as it works to overcome technological gaps. Section 6. The road ahead and global implications. So what does the future hold? In the near term, China will likely continue to focus on achieving self-sufficiency in mature node chips while making incremental progress in advanced technologies. The country aims to triple its output of artificial intelligence chips by 2026, rushing to reduce dependence on foreign suppliers like NVIDIA. China's 15th Five-Year Plan, which began in 2026, prioritizes capability building and technological self-reliance over rapid expansion. This suggests a more disciplined, long-term approach to semiconductor development. For the West, the challenge is twofold. First, maintain leadership in cutting-edge innovation. Second, avoid overestimating the impact of restrictions while underestimating China's capacity for sustained investment and problem-solving. It is also worth noting that the semiconductor industry is deeply globalized. Complete decoupling is neither practical nor desirable for most stakeholders. Many experts believe the most likely outcome is a bifurcated ecosystem, with parallel supply chains serving different markets and applications. For businesses and investors, this environment creates both risks and opportunities. Companies that can navigate the complex regulatory landscape, adapt to localization requirements, and identify areas of mutual benefit may find pathways to participate in China's growing semiconductor market. Conclusion. Let us wrap up with a few key takeaways. First, China has made remarkable progress in semiconductor technology over the past 5 years. From AON implanters to lithography prototypes, the country is systematically addressing gaps in its domestic supply chain. Second, China still trails the West in the most advanced chip production, particularly in extreme ultraviolet lithography and sub-7 nanometer processes. Closing this gap will take time, sustained investment, and continued innovation. Third, the geopolitical dimension cannot be ignored. Sanctions have accelerated China's push for self-reliance, while also creating uncertainty for global supply chains. Finally, the chip race is not a sum game. Advances in packaging, materials, and design can create new opportunities for collaboration even amid competition. Whether China catches up to the West in semiconductors may be less important than how both sides manage this critical technology for the benefit of global innovation and stability. Thank you for watching. If you found this video informative, please like, subscribe, and share your thoughts in the comments below. What do you think about China's chip ambitions? Can they achieve true self-sufficiency? Let us know. Until next time, stay curious and keep learning.